Hey guys, and welcome back to C# Mallorca. My name is Matthew, and in the last video we were introduced to types and variables in C#. So if you didn't see that video, go check it out. I'll put a link to it in the top right hand corner. In today's video we're going to work through a few more types and also go through a few examples of how we might want to use them in our applications. If you find this video helpful, please give it a like, and if you want to see more, subscribe and turn on notifications so that you can be notified as soon as the next video is available. So without any further delay, let's get going. So, in the last video we worked with the string data type and the integer data type, and today we're going to go through a few more data types and examples and touch on a bit more theory as well. The theory I'd like to go through is with regards to the two categories of types that we have, which are reference types and value types. This basically determines where in memory these variables are stored, and it does become something quite important to be aware of when it comes to passing variables around as parameters within methods and also when copying variables. The two different areas of memory are the heap and the stack. The heap is for the reference data types and the stack is for the value data types. The stack is good for storing smaller pieces of data that you need really fast access to, and the heap is more suited for larger, more complex data types. This is handled automatically for you based on the types you use and how you use them. Something else quite important to note is that your value types are actually stored with their values on the stack, whereas with reference types, their values are stored on the heap but are pointed to those memory addresses on the heap where the values are stored is what is kept on the stack. So your reference variables essentially just hold a pointer to where the data is stored on the heap. This is where the consideration needs to come in when it comes to copying variables and passing them around as parameters. By default, when you are working with reference types, you pass a copy of the address pointer to methods when you pass them as parameters, and you also just generate a copy of the pointer only when you make a new copy of the reference type variable, whereas with value types, when you create a copy, you actually end up with two copies of the actual data, unlike the copy of the reference type, which is just a copy of the pointer to that original data on the heap. Hopefully this explanation and the diagram illustrates this clearly, but we are going to step through an example as well. One of the main reference types you'll be working with is the class type. Classes are basically objects that we can use to group together functionality into one unit. For example, we could have a person class that has various properties on it, such as first name, last name, date of birth, etc. This is way more convenient to work with than having a bunch of different variables floating around in the main area of our application that might need to be passed around individually when processing occurs within our applications. Let's head on over to Visual Studio to create a class with a few properties on it using a few different data types to help us get more familiar with things. We're using a C# console application again, and in case you didn't see the video on how to create a C# console application, go check it out. I'll put a link to it in the top right hand corner. The first thing we need to do is define the class. We've already seen this before. The program class that our app is contained in is actually itself a class. Normally, it's preferable to create classes in separate files within your project file structure. So let's go ahead and add a new class to our project by right-clicking on the project and choosing Add Class from the context menu. We'll call the class person.cs and then click on Add. So let's create two properties on this person class. Don't worry too much about the syntax just yet. When we go through classes and their members in a separate video, we'll cover this in more detail. So let's type in public string first name open curly brackets get semicolon set semicolon close curly brackets. This get and set are just functions that are used to get and set the property value. We can expand on those functions when we use properties to access and control private fields, again, which is stuff we'll cover more in a separate video. Now let's type in public string last name open curly brackets get semicolon set semicolon close curly brackets. We'll just use a first name and a last name property for now, so let's head on over to our program.cs file and use this class. To use this class, we need to create an instance of the object by using the following syntax. person1 equals new person, open brackets, close brackets, semicolon. Now that we have an instance of this type, we can assign values to the two properties. So let's do that by typing in person1.firstname equals, in quotes, Matthew, semicolon. And then on the next line, let's type in person1.lastname equals, in quotes, Mac, semicolon. Then let's write the values to the console by typing in the following: console.writeLine, open brackets, hello in quotes, plus person1.firstname, plus quotes with a space, plus person1.lastname, close brackets, semicolon. Don't forget to put in the call to the console.readLine at the bottom here, and let's run our application and see what we get. You can see the greeting to the person written to the console. Okay, I'm going to comment this out, and then let's jump on over to an int type again and type in int age1 equals 28, semicolon. Then let's make another variable called age2 and assign it the value of age1 by typing in int age2 equals age1, semicolon. Now, since we're working with a value type, we now have two actual variables that are currently holding the same value, 28. They are two variables though, and not just two pointers to the same data, which we'll illustrate shortly with the person class. Now, let's change age2 to a different value by typing in age2 equals 38, semicolon. Now let's write the two values we have to the console and see what we get. So type in console.writeLine age1 and then console.writeLine age2, and then run the application. As you can see, these two variables are written to the console, each with their own unique values. Okay, so now let's comment this out and then go back to our person example and then create a second person as a copy of the first person by typing in person2 equals person1. Now let's set this person's first name and last name as follows: person2.firstname equals John, and then person2.lastname equals Smith. Now let's write them both to the console. So we'll add in console.writeLine hello plus person2.firstname plus space plus person2.lastname, and then run the application. As you can see, both lines point to the John Smith values, and that's because, unlike with the age int variable example, these are two copies of the address to the same data in memory. So no matter which person variable we work with, they both point to the exact same location in memory and the exact same data. This is something very important to be aware of when working with objects. If you don't familiarize yourself with this concept quite thoroughly, you will find yourself running into some frustrating times in the future. Alright, so let's instantiate this second person object properly so that we don't have two variables sharing the same data. Now we have our two separately instantiated person objects that don't share any references to data. Let's move on to a date time example now. Let's head on back to the person class and add a date of birth property by adding in public date time, date of birth, get, set. Let's touch on constructors here as well very briefly. When you create a new instance of an object, you're calling a special method known as a constructor. By default, a class has a parameterless constructor that you call when instantiating an instance of the class. As you can see here, when we create this instance of the person class, there's an open and closed brackets that has nothing inside. That's the default parameterless constructor being called, which doesn't have to be stipulated in a class definition if there are no others specified. It's just automatically available. If you define a constructor though that takes in some parameters, then the default public parameterless constructor is no longer available and has to be defined if you want it to be available for use. So let's add a constructor so that we can supply a first name and last name when instantiating an object. Let's head on over to the person class and add this constructor using the following syntax: public person open brackets string first name comma string last name close brackets open curly brackets. This dot first name equals first name semicolon. This dot last name equals last name semicolon close curly brackets. The this keyword is used to refer to the current instance itself. Now that we have defined a constructor, let's head on over to the program class and see what we have. You can see that Visual Studio is yelling at us about this instantiation of the person object. That's because we now have a constructor present that accepts parameters, which means that the parameterless constructor is no longer available. So we either need to define the parameterless constructor or we need to use the other constructor. It's quite a nice practice to avoid using the parameterless constructor in scenarios whereby you don't want objects to be instantiated into an invalid state. Now, we aren't able to create a person object without a first name and last name, so let's supply the first name and last name like this, and then we can also remove these 2 lines of code, making the initialization process even simpler. Now let's just do the same for the second person as well, so that they are also instantiated using the new constructor, and then just get rid of these 2 lines as well since we no longer need them. Now let's look at initializing the date property to a value. When populating a datetime value, we can use one of its parameterized constructors. When we type in person.dateofbirth equals new datetime and open the brackets, we can see here that IntelliSense is showing us one of 12 constructors that we can use to create an instance of a datetime value. If we click on the arrows to view the other constructors, we can find something suitable for what we want to use. Let's use the one that accepts 3 parameters, year, month, and day. So let's punch in the year, 1983, the month, 1, and the day, 20. Now let's include the date of birth in the print to the console like this and see what we get. As you can see, the greeting now includes the date of birth as well. If we want to print out a prettier date, we can make a call to the toLongDateString method on the datetime object like this, and then when we run the program again, we can see a much prettier formatted date. Something else very useful is the Boolean data type. This is just a type that lets us store a true or false value. So let's add a property onto the person object indicating whether they are subscribed to my channel or not. So let's go to the person class definition and type public bool is subscribed get set. Now, back in our example, let's set the first person's isSubscribed value to true by typing in person1.isSubscribed equals true. Then let's update the console write to include and your subscription boolean is plus person1.isSubscribed. And then we do the same for the person2 write line. Let's run the application now and see what we get. As you can see, the first person is subscribed and the second person isn't. But we didn't set the second person's isSubscribed property to false. So what happened there? When it comes to classes, properties are initialized to their default values upon instantiation. For numbers, that's 0. Strings, it's a blank string. And for Boolean values, it's false. That's why the second person is not subscribed. Remember though, if you're working with variables in your code, they are not initialized just by declaring them. For example, if I type in bool is subscribed and then try use that value on the console by typing in console.writeLine is subscribed, you can see Visual Studio shouting at me here because we have to initialize the variable before we can use it. Let's touch on the decimal type now. Let's say, for example, we want to store our height on this person class. Let's add a decimal property to store the height in centimeters. So we go over to the person class definition and type in public decimal height get set. Then in our program, let's set the height for our 2 people by typing in the following. Person1.height equals 176.54. Now you can see that Visual Studio is yelling at us again. That's because we need to suffix the literal value that we supplied with an M like this. This is how we confirm to Visual Studio that we are supplying a decimal value. This comes in when we work with type inference, which we'll cover later on, but basically we need to be able to tell the compiler that we want to use a specific numeric type. You'll remember from the first video on types, we have quite a few options with regards to the numeric types based on our needs. When we supply values for the numbers, we can use the suffixes to stipulate the type. This also comes in handy when you're storing values for calculations and the way the compiler handles arithmetic with regards to types. If you're dividing 2 numbers without decimals, the compiler will assume them to be integers. So if you divide 4 by 3, you will get 1. Because the types are both inferred to be integers, so the result is calculated as an integer because those are the types you have essentially worked with. This is usually not the desired result. If you stipulate that these are decimal values like this, then you will see your result the way you most likely wanted to. This is something worth keeping in mind because you can sometimes get some very undesirable results when working with numeric values if you aren't fully aware of the way the types are inferred and work together during mathematical operations. So let's continue to set the second person's height like this, and then we can print their heights to the console as well by including and your height is plus person1.height, and then we can do the same for the second person as well, and then see what we have printed to the console. Lovely. Alright guys, I think we'll leave it there for now with regards to types. We do still need to go through a bit more information about strings, which we'll do so in the next video. And then the 2 videos after that will be about structs and classes. After that, we're going to get to more of the fun stuff like inheritance, generics, and collections. I hope you found this video helpful, and if you did, please remember to give it a like, and if you want to see more, subscribe and turn on notifications so that you can be notified as soon as the next videos are available. Take care, see you next time.